Good morning, everyone, and welcome to this NLA webinar on sustainable materials, a pathway to zero carbon. I'm Peter Murray, Curator-in-Chief at New London Architecture, and I'll be moderating proceedings this morning. Now, the NLA Zero Carbon London report, which was launched in November last year, included an extensive member survey which outlined some clear priorities for London and its built environment in response to the climate emergency. And without doubt, embodied carbon emerged as a really critical issue to consider. And so the focus on retrofit, circular economy, and ultimately the choice of materials in buildings is key to discussions on how we deliver buildings in the future. And today we're joined by some great speakers who will present research and case studies about reusing and recycling materials, as well as choosing more sustainable low carbon options to tackle embodied carbon. And this event is part of the NLA year-round net zero program. And I'd like to thank our program champions, Civic Engineers, Elementa, HTS, Hawley, Wicona, London and Partners, and Watermans. And also today, I'm very pleased to announce that the NLA is part of a coalition of almost 100 partner organisations right across the built environment sector and driven by the UK GBC, who will support the delivery of a built environment virtual pavilion during the UN's COP26 Climate Summit in November later this year. And so we'll be focusing our attention on promoting the climate agenda through our activities at NLA and our events over the next few months. And events such as this are really useful in addressing some of the barriers and in promoting best practice amongst the industry. Now, before we start, I'd just like to remind you, as usual, if you want to ask our speakers a question, please do put it into the Q&A box on your screen, and I'll ask our panel to respond after the presentations. So to start us off, I'd like to introduce our first speaker, Isabel Vernon Avery, and she's a consultant, climate change and circular economy at Arup. Isabel.
Great, thank you, Peter. Lovely to be here today. Good morning to all who are on the call. And it's great to have this time this morning devoted to the topic of sustainable materials and net zero carbon. If we could go to the next slide, please. So as Peter said, my name is Isabel Vernon Avery and I work in Arup's Circular Economy and Climate Change team. And for a bit of context about Arup, as a firm, we really recognise the challenge that we face in regard to climate change and kind of critically the role that we have as designers of the built environment in mitigating these impacts and adapting. And we're really interested in the material reuse within the built environment because we see it as an absolutely integral way for us to reduce our emissions. Next slide, please. But before I kind of dig into the project I'm going to speak about today, I just wanted to kind of flash up some numbers, and I'm sure many of these will be kind of obvious to some of you on the call, but I think it's really critical that we understand the challenge we face and also the construction industry's place within this. As we know, the built environment contributes significantly to emissions on waste and emissions. And for me, on this slide, the standout fact is that 95% of material value is currently lost due to downcycling and demolition. So as engineers, as architects and designers, we have a huge role to play in creating a solution to these challenges. Next slide, please. And so the reuse of materials is foundational for us to meet our net zero targets, and reusing materials in projects will significantly reduce the industry's carbon emission. And just to kind of be clear on my definition of reuse, what I mean when I say reuse is that use of a reclaimed material that has previously been part of a building that already exists. And as an industry, we have to establish a viable secondhand market that deals with the kind of storage, the cataloguing, the recertification and the resale of these materials. And we believe with kind of activities like the project I'm going to speak about shortly, conversations absolutely like this one today, and government policy change that we can achieve that. So if we move on to the next slide, please. So to kind of achieve net zero, material reuse is both seen as an enabler and a blocker, and therefore became the focus for this innovation project with Grosvenor and several other partners. And at Arup, we've had several kind of ongoing conversations with Grosvenor on the lessons learned from projects such as circular building and how these could be applied to Grosvenor's portfolio and projects. And this led to a conversation in autumn last year, where Arup and Grosvenor set a scope for a green innovation project. And Grosvenor and Arup kind of drew on their collective networks to find some really interesting collaboration partners. And together we virtually sat down to explore kind of overcoming these barriers to material reuse in London. And we identified 4 core areas to explore. And these were reuse potential, which was led by Elliott Wood, material passports, which was led by Orms, material sourcing, which was led by Arup, and then specification banding, which was led by Heta Architects. And this research, it was really, really exciting because we had the opportunity to apply our research to a real building while it was still at RIBA stage 1. And the team was really able to kind of get in and test their thinking in a live situation with the tenants still in situ. And we've already seen some impact of this project, such as the demolition and the salvage advice coming on far earlier in the process, and a different approach to procurement. And so in the next couple of slides, I'm just going to run through at a very high level these work streams and the outputs created. And at the end of this presentation, I will share a kind of link to the resources that you can then go on and access and investigate after this call. So if we can move to the next slide, please. Thank you. So for reuse potential, Elliott Wood led this research. And this was really responding to a challenge that we see at the moment where, there's often very poor information into the materials that are present already within a building. And especially kind of looking at the structural material that sits behind a finish. And as a result, it's often quite hard to plan for disassembly and material reuse because you just simply don't understand what you have in your building already. Next slide, please. And so this research focused on determining that structural material behind the finish. And the work stream produced Full Circle to Reuse, which you can see on the slide here, which is a 12-step guide to facilitating reuse and to support that planning for disassembly. And the framework will help architects, developers, contractors, demolition firms to take those steps to implement reuse on their schemes. And if we move to the next slide, you'll see that we mapped these 12 steps across the RIBA plan of work, so that we indicated at each proposed stage which new steps should be undertaken. And these steps to reuse, they really kind of promote a process of obtaining a reuse audit rather than a demolition audit. And we kind of say in our guide that this needs to happen right up front from the outset, certainly before RIBA stage 0, but ideally even before a project is being considered for that redevelopment. Next slide, please. And so moving to the next work stream and material passports. And for those of you on the call who haven't come across the material passport before, quite simply, it's just a document that contains all the information that you'll need in order to reuse the material. And when you think of like new materials that come from a manufacturer, they come with this comprehensive set of information. And a current challenge for material reuse is that lack of information. And as a result, there's often quite low confidence for kind of designers and contractors to use that material. And while material passports are definitely understood as a solution to this, the implication can be unclear sometimes. And in addition, material passports are kind of understood as these standalone documents containing a vast amount of information about a component, and potentially a project team would manage thousands of these material passports. Next slide, please. So Orms sought to really clarify and simplify that process. And a material database that is produced by the design team has been proposed. And this is set to kind of act as a central repository, which could link into the design team software, allowing them to kind of maximize that existing on-site material reuse. And a contractor could add in a new material that they procure, both new and salvaged. And then once construction is complete, that database could link to facilities management software, providing that access into maintenance information. And I think the kind of longer term and quite interesting bit is, how can we be creating these databases to serve as an archive for future design teams? This isn't a problem that just affects us now. This will, re-emerge at the end of the building life. Next slide, please. And there are some future opportunities that the team are quite excited about, including kind of exploring material warehousing and then potentially connecting into kind of material trading platforms so that you could start to see other materials from between projects, between kind of portfolios across a region, across a city like London, and start to kind of really reuse those materials between projects to understand their value. Next slide, please. And so the sourcing of these pre-used materials is quite challenging. At the moment, there's kind of quite limited take-back or refurbishment schemes. And while kind of salvage yards and reuse platforms do exist, and they're definitely, very strong in Europe, there are still kind of some quite cool challenges, such as variable supply. And these sourcing challenges absolutely can be overcome, but it just requires very strong collaboration across the supply chain. And I think importantly, a change to the workflow for designing and developing a project. Next slide, please. And through this work stream, we try to kind of address and challenge the perception of this sourcing as being complex and time consuming and costly by breaking it down into smaller steps that are achievable and practical. And so to break this down, we looked at these 3 typical kind of sourcing scenarios. So same site, site to site, and reuse supplies. And if we can go to the next slide, please. And as a result, we developed this workflow, which is currently grayed out because it's quite complex, but the flow highlights the additional steps that will be required for kind of from project inception through to procurement and through to construction to really successfully incorporate those pre-used materials. And we found 2 stages to be absolutely critical, which were the design stage and the procurement stage. So, designers and architects, they kind of know what materials are available based on their extensive experience and can get through design stages quickly because they have that immense retained knowledge. But if you kind of really want to dig in and facilitate reuse, you have to put in more time to investigate that supply chain and to engage with suppliers to understand if a reused material can meet your design requirement. And, while material passports will help this process as they kind of gain momentum, inevitably some of this time will fall on a project. And that time is just really needed for learning and searching and design iteration. And this needs to be explicit within that procurement so that the entire project team embeds reuse. And, design teams kind of need to be thinking around like how they write a specification, how do we incentivize contractors to really look for that reused material first before we look for a new product. And as I said, this is quite a complex slide. There's lots of information. On the 9th of June, Arup and London are hosting a webinar, and I'll share the link at this, and you'd be very welcome to join. And if we can move to the next slide, please. So finally, specification banding was led by HETA and reviewed reuse strategies and explored the trade-off between generous space allowances, which permit kind of the greatest number of material solutions to be adopted, and also kind of the efficient use of space. And it predominantly looked at the question, how do you design so that when you procure a reused material, you are minimizing those constraints? So you design with the loose fit, so you basically have the best chance. Next slide, please. And often a blocker is that flexibility isn't included in the design. So the work stream defined kind of practical build outs that could be achieved and looked at quality levels as to kind of what would be acceptable for different reuse options. Next slide, please. And this work stream defined kind of 4 core metrics. So quality, and then you've got application 1, which looked at where will the material be used, so front of house or back of house. Application 2, looking at visibility, will it be a build-up finish or a final finish item, and then finally size. And these metrics have been added as another column in our material passport database to enable each material to kind of understand which specification band it belongs to. And like material sourcing, we've got a webinar to launch the guidance on the 30th of June, and the link will be shared at the end of this slide deck. So if we can move on to the next slide, please. I think, the thing here is we're really at the start of a process in terms of developing a mature material reuse market. And we really hope that this acts as a kind of practical guide to stimulate debate and action. Next slide, please. And I think, finally, I just really invite everyone on the call to go and visit the Grosvenor Material Reuse site. And there's a link on the slides that will be shared. Please go and download our resources. You can access past webinars and upcoming webinars. And we really value your feedback. So please do get in touch and join the Reuse Network. And we'd love to hear from you. And if we can just go to the final slide, please. Just on a kind of personal note, it's been a really fascinating project to be part of with Grosvenor. And I'm really glad we had the opportunity today to share this with you. So thank you very much for listening, and I'm really looking forward to the discussion and the rest of this session, and also beyond today, continuing this conversation as we work towards net zero. Thank you.
Great, thank you very much, Isabel. That's really super useful research, and thank you for sharing it with us. And now I'm pleased to introduce Graham Hurrell of Wicona UK and Hydro Building Systems UK, who's going to talk to us about recycling facades. Graham.
Thank you, Peter. Thank you, Isabel. Okay, this is, come on to the first slide, please. Okay, just a quick introduction. Wicona is a facade system brand within the bigger group Hydro. So you'll see both names mentioned during this short presentation. It's quite a fast tour of quite a big topic. So there's plenty more to discuss afterwards with anybody who wishes to. Next slide, please. Just a quick question to start with. Two different materials, both used in construction quite a lot. Timber, of course, is a great material from a carbon point of view because it absorbs carbon. But one of the things that happens with timber is as you recycle it, it degrades. So it's not infinitely recyclable and reusable. And we wind up with probably with biomass at the end of the cycle or something like that. With aluminium, we are fortunate in construction that it is almost infinitely recyclable without any degradation of physical characteristics. And so we're going to look at how we can use that to give us some low carbon, low embodied carbon in our materials. Next slide, please. Just a quick overview as to how we've sort of researched this particular low carbon technology. Hydro does mine aluminium. It creates aluminium from bauxite ore, so we have a mining presence. Obviously, what we're looking to do is minimize that. We cast aluminium, we extrude aluminium, we use and generate our own hydroelectric power as part of that process. We make products and we do recycle and reuse aluminium as well, and you'll see those all come up in the coming slides. Next slide, please. So, in addition to being very recyclable without degradation of physical properties, aluminium has another advantage. The energy input that we need to recycle aluminium is extremely low, just 5% of the energy that we need to create it from mined bauxite. So it's recyclable and it has a low energy input, and obviously that has CO2 impacts as well. As a consequence, across all sectors, a huge proportion of aluminium is still in use, either in its original or recycled use. And in construction, there are studies out there that tell us that around 90% of it is actually recycled. So that gives us a good advantage. Next slide, please. Before I go on too much, I just want to talk about pre-consumer and post-consumer scrap or waste, because they are quite different. Pre-consumer is effectively production inefficiency wastage. There will always be some, but it's never had a use. It can be remelted and reused, but it's never actually had a use in a building or any other product or application. Post-consumer scrap is very different. In our context, it's facade and windows that have been used in a building for 20, 30, 40, 50 years and have had their full use. And that gives us a very different embodied carbon view when we look at EPDs and life cycle analysis. So that's the difference between pre and post consumer. And you'll see we talk about this quite a lot. Next slide, please. So again, just to introduce a couple of tags and labels. Circal is Hydro's brand for recycled materials from post-consumer scrap. And 75R means an aluminium alloy that uses 75% of its composition is post-consumer scrap. The other 25% is a blending with some pre-consumer scrap. and with some primary metal just to get the alloy blend exactly right. But the 75 signifies a minimum of 75 post-consumer scrap. And next slide, please. As we will see, this post-consumer scrap in our case comes from building demolition waste. It comes from old facades in existing buildings that are either being renovated and the facade removed and replaced, or the building's been demolished. Hydro has invested hundreds of millions in a processing plant which takes existing facade material, sorts and sifts it with quite a lot of clever technology. And I'd urge you to have a quick look on YouTube. There's a 2-minute video. If you just put in Hydro Circal, it will come up in YouTube search, and it explains a lot more about the process. But from this process, we are able to take segregated building, construction, demolition, aluminium waste and turn it into new aluminium billets. And we'll see what that does to the carbon, embodied carbon, in a minute. Next slide, please. Of course, we can't just, you know, we're a company, so we need to have third-party accreditation. So every input of scrap is accredited by DNV-GL. It meets the European Waste Directive, so it truly is building waste and building scrap that goes into the raw material. So there is third-party accreditation of the scrapping and the casting process into the new billets, just to give everybody confidence that it is what we say it is. Next slide, please. So we've got a very clever process. Do look at YouTube. What does it mean in terms of embodied CO2? I'll start wrongly on the right-hand side of this chart, and these figures come from international aluminium associations. They are, if you like, independently verified. If we take aluminium that is primary aluminium from mining, and it's produced using coal power, as they do in China quite a lot, it carries 20 kilos of CO2 per kilo of aluminium. If we whiz right across to the far left-hand, nearly the far left-hand side of the chart, passing by European averages and some other hydro products, if we look at the Circal 75R from the post-consumer waste, that carries a CO2 footprint of 2.3 kilos per kilo of aluminium. So quite a big difference in the amount of embodied carbon to produce that material from the recycled material. Next slide, please. Just very quickly, for those of you who don't know, we take a nice aluminium log, which is what comes out of the casting factory from our recycled material. We put it through a die and we create any type of profile to make any type of curtain wall or facade product like a door or a window frame. So that's just to explain how that winds up being. Next slide, please. And all the way through to the images on the right. Effectively, there are 2 pieces of aluminium made from our recycled material. In between is a piece of some polyamide insulators, which are actually also recycled. And that technology, that input now constitutes about 80% of our standardized systems. So it's not now available on request as it was when the first technology first came out. It's now a standardized component of a curtain wall or a window system. Next slide, please. And then it ends up being incorporated into a full building facade. Next slide, please. Okay, so what impact would that material production technology, the recycling, have on a typical facade? So if we stop talking about kilos per kilo and talk about kilos per square meter of facade, let's just see how it builds up. Next slide, please. And right through to the image on the right hand side. Yeah, perfect, thank you. So on the left is what we call a traditional unitized design. And on the right is a more evolved design. Now that's before we change anything in the aluminium. So what we're doing here is combining a more effective and efficient design with low carbon materials. So we will be changing gaskets as well because they carry a carbon burden, and we'll be using recycled polyamide insulators as well. Okay, next slide, please. Okay, so On the left is our traditional facade, and that has about 106 kilos of aluminium in a 2.4 by 3 meter, 3.6 meter panel. This evaluation is done without glass, by the way. If we look at the more effective design on the right-hand side, you can see that just the design change reduces the amount of aluminium to 80 kilos. So there's already quite a significant reduction, and the gasket numbers also reduce. So we're reducing the mass even before we reduce the carbon content of the material. Next slide, please. And the right-hand side one as well. There's a number of builds on this slide. Perfect, thank you. So on the left-hand side, and I'm annoying, sorry, I've swapped these around now. So I'm showing you the new design on the left-hand side. And if we apply those embodied carbon numbers to the improved design, we see on the left-hand side of the graph that we end up with 207 kilos of carbon in the facade panel through aluminium, recycled thermal brakes, and efficient gasket design. Okay, so that's on the far left at 207.7. Now I'll jump over 2 or 3 steps because there are a number of other steps here. But if we took our worst case and we had a slightly less efficient design on the right-hand side, what we might call a traditional design, something that we would have had 3 or 4 years ago, and we produce it with the highest carbon aluminium, we actually go right up to 2,184 kilos of carbon in the same panel. So the use of recycled material, post-consumer material, and a more effective design, and using recycled materials in the thermal brakes does have a significant impact on the amount of embodied carbon per panel, and therefore per facade. Next slide, please. So one of the things we've been looking at is what are the drivers in the construction market, in the building market for a low carbon product. Interestingly, the building regulations are still focused on operational carbon, and we've scrutinized the new DOC-L that's coming, and we still see operational carbon as being the preoccupation. If we look at BREEAM, and I'm no BREEAM expert, and I would welcome any further education. If we look at MAP 1 promotes the use of sophisticated and very advanced life cycle analysis tools, but doesn't seem to create any specific embodied CO2 targets for the materials that are evaluated by the life cycle analysis tools. So I still think that green building schemes are possibly missing something. As I say, I would love to be corrected. Despite that, we have now seen very strong client interest in low carbon facades, low carbon facade materials through developers, commercial property owners, main contractors, and their specification teams. So we know that there's a genuinely strong interest in the topic, and that won't surprise anybody who's in this session today. Okay, just one little word to say, be careful of sometimes embodied CO2 numbers. Because you have to look at the EPD and see what scopes and elements of the process are encompassed by the EPD, and the same with the life cycle analysis. So please examine low carbon numbers very carefully as to the start and stop points of their processes. Next slide, please. This will be quite a quick one, just to show you an example of an EPD. Again, independently verified. These EPDs do include the glass element as well. And if you just go to the next slide, and one button push, please, just to blow up the panel. Yeah, so there we see the GWP, global warming potential, and the EPD that we have for the product has got the 2.3 kilos built into the window size and everything that we've just seen on the front page of the EPD. But of course, all the other factors in the EPD should also be considered. It's no good us having a low carbon product that does a lot of damage to the ozone layer. That doesn't really work. So look at all the other factors that go with the low carbon input. And next slide, please. Just very quickly show you 3 projects which are using this technology already. There's a large one in Norway, which is the big image, and a little closer to home, there's a building for Royal College of Arts in Battersea, which is using the Circal. And interestingly, this produced a saving of 135 tons of 135 tons of CO2 vis-a-vis European average, and that was probably manufactured now 2 years ago, and our supply chains moved on such that it would generate a 250 ton saving, if it were produced now. So that's the RCA in Battersea, and Ilona Rose House in Soho also uses Circal for the window frame material for similar reasons. And just the last slide now, please. Thank you. So just some sum ups. Aluminium is great to recycle without deterioration, but that's also a low carbon process. So that's a nice coincidence. Okay. Building facades can be and are being used as a source of post-consumer scrap. Controlling and sorting all that material inputs is a challenge and requires investment and discipline. Difference between pre and post-consumer scrap we've discussed. I would say EPDs and LCAs will show good material technology and good design, but examine them carefully. And yeah, I'd like to one of the challenges that NLA asked me to comment on was, is low carbon and low embodied carbon really in the legislation or in the standards that we work to? And I think there is still a way to go. So I think that's me done for now. I'll be happy to answer some questions when we get to the end of the session. So Peter, back to you.
Great. Okay, well, thank you very much, Graham. And we'll see if in the discussion later whether our panelists or indeed anyone in the audience can respond to your question about BREEAM and CO2 targets. So thank you very much. And now our next presentation is going to be from Yara Mashnuk, who is an environmental design engineer at Elementa. Yara, over to you.
Thank you, Peter. Thank you. Morning, everyone. Thank you for taking the time to join us today. I'm going to be speaking on sustainable materials and touching on some key conversations that should be considered early on in the design process. Next, please. So I work within the sustainability team at Elementa Consulting, which is a firm in the UK, part of a wider group called Integral. We have many offices across the world, and we provide a list of services from mechanical, electrical design, sustainability services, public health, and fire engineering as well. Next, please. So to give everyone a bit of a background specific to the topic we're looking at today, we have experience in carrying out full building life cycle assessments and creating roadmaps to reduce embodied carbon at a building and a district level, and looking at circular economy appraisals. Next, please. And just to touch on some key highlights specific to embodied carbon as well, many employees at Elementa were involved in the LETI embodied carbon primer, led by my colleague Clara. And then this led on to developing a refrigerant best practice guide because of the importance of being aware of the high global warming potential impact of refrigerants. And more recently, the publication of the CIPSE TM65 methodology, which I'll touch on a little later. But this helped us conduct our latest study on the embodied carbon of heating and hot water systems, specifically in residential schemes. Next, please. So we can go on to the next slide. I'll be talking about the impact of materials. And as we all know, the reason we're having this conversation, we need to reduce our carbon emissions as soon as possible. The embodied emissions really contribute to this. This color scale just represents the annual global temperatures from 1850 to 2017, taken from an IPCC report stating that the building construction industry needs to focus on reducing its carbon emissions by 80% by 2030 if we want to meet our 2-degree reduction target. Next, please. So the embodied carbon emissions are all the emissions associated with the materials and the construction processes throughout the whole life cycle of an asset. So it could be a product, it could be a built asset, and this is all related to the product making, the construction use, and then the end of life of the product as well. Next, please. If we look into the original definition of calculating our embodied carbon, it's the multiplication of the quantity of the material by the environmental impact. So the environmental impact we're talking about in this case is the global warming potential, and this is what gives the carbon footprint. Next, please. So what these calculations help us do is quantify the total impact of our whole life carbon, and it fills in those gaps that haven't been a major focus over the last decade. So as design teams, what we need to do is really both look at the operational carbon, which really has been a driver, and then now looking into the embodied carbon as well. And this helps us work towards our zero whole life carbon approach. Next, please. And this forms part of a wider methodology. So currently in place, it's the whole life carbon assessment. And this is the methodology used to assess the global warming impact of a built asset over a life cycle, including stages A, B, C, and then D if there's any reuse or recovering involved. And what this does is it can help calculate the global warming potential of the whole building or a whole district, depending on the focus. Next, please. So just on the next slide, we're going to be talking about the low embodied carbon principles that are very high level key discussions that should be had and communicated early in the design process. So first and foremost is discussing, less is more, building less. So this is all about the brief that's originally set. Has retrofit been considered? Is an entirely new building even necessary? Has the brief really been interrogated against the client needs to represent the most efficient solution? And then looking more specifically into the material choices. So when you're looking at MEP, is there ways you can incorporate passive design to design out some of these MEP equipment? And when you are specifying it, focusing on looking at lower weight components. And then building low carbon as well. So understanding what these big ticket materials are, what you can do to avoid them, where you can source them more responsibly, and really focus on these big wins and do some investigation into alternative solutions that you could incorporate into your design. And finally, it's building for the future. So thinking about the adaptability of the project, how early on in the design you can make consideration for the future of the building. So working to a regular grid, with removable partitions, and this will allow the building to adapt, creating soft spots in the architecture. And then thinking about the end of life in terms of the disassembly, building in layers so that the building can be maintained and then it can be replaced. And then using dry building methods as well as encouraged for things like mechanical fixtures rather than adhesives. And all this helps the end of life and the circularity of the project. Next, please. So this is just a visual showing the impact of materials, and this really varies, and it's important to be aware of which projects should be minimized or considered more carefully. So the pink numbers refer to projects used more commonly in architectural elements, and the blue ones more typically seen in MEP. These embodied carbon coefficients are given from the ICE database, and they're given as world averages. And I think something that really stands out is the impact of aluminium, and as Graham rightfully explained in detail, aluminium is really important one to consider and look where this is being sourced from, and because of the longevity of it, where it can be recycled and reused rather than extracted raw. Next, please. So touching on concrete's really favored in the industry because of its strength and its durability. And this is important because it also means that it would need less maintenance during the lifetime as well. In concrete, Portland cement is a major component, and this contributes to having a significant embodied carbon content. This is why when talking about concrete, it's important to explore cement replacements. In superstructure elements, we can see around 50% cement replacement, and in substructure, we've seen over 80% of cement replacements. And in the UK, this could be typically pulverized fuel ash, which is commonly used. Something to be aware of is when asking or allowing the contract supplier to use higher volumes of cement replacement, this does need longer time to cure, so it does affect the procurement process. And it's something that should be factored in. And the other component of concrete is the aggregates as well, which also can be recycled from previous products. Next. So moving on to steel. Steel is something that's used quite a lot, and we see fully reinforced steel concrete buildings. A way to reduce this is looking into EAF steel, which goes through the electric arc furnace process. And this can reduce the impact by around 75%, but it's important to know what this process can be used for. So can't be used for things like cold rolled steel framing. It can be used for standard sizes only. So when doing steel structure, it's important to look at, you know, you're going to need specific sizes. So how can this be sourced? Can it go through the EAF steel process? And another quite a good steel product to look at is looking at castellated beams. So the principle of this design is that you can increase the depth of the beam without increasing its weight, at the same time maintaining or increasing the strength as well. Next slide, please. And the last material I'll touch on in a bit more detail is timber. So timber has a lot of advantages in terms of its embodied carbon content. It is really low. It adds elements of biophilia to the design. One main thing to really look at when sourcing timber is that it's from a sustainability sourced forest, and this is really, you know, enforced and pushed in regulations. In terms of the actual design and sizing of it, using deeper, skinnier beams, and considering ways to reuse the wood at the end of life. So this is a little bit more challenging when the wood has been treated, whether it's paint and color or whether it's fire treated. So untreated wood can be reused all the way down to chipboard or particle board, but this is a bit more challenging and less achievable with treated wood. So it's important to think about the circularity of timber specifically. So I'll move on to go into just a few case study examples. So the next slide shows case study 1, and this is a residential project. It's a student accommodation build, and the aim here was to carry out a life cycle assessment on one typical floor plate where the client wanted to explore 3 different construction types. So it was concrete, mass timber, and then the HSS steel structure as well. Just looking at the high level numbers, you can immediately see the impact of using timber, reducing this to less than 32% of the baseline, which was concrete in this situation. And then looking at steel, it skyrockets quite high, and you can see the impact of that in terms of the embodied carbon content. And the next slide shows this broken down further into the life cycle stages. You can see, you know, the focus is really in the A1 to A3 stages, which involves the extraction and the processing of this material. And again, you know, steel, really, you can see that it's, the global warming potential is around 1.5 times the concrete. So next slide, please. Case study 2 is an office, and the aim here was also to carry out an embodied carbon assessment comparing different structural materials. So it shows 2 different options that they had, one with a 5-story parking garage, one with a 2-story parking garage. And the 3 different structural materials they really looked into was, first of all, just a standard concrete, and comparing this then to a 40 SEM concrete, which involves supplementary cement materials in it. And then the third option was to use that 40% and then also use glue laminated timber within the structure as well. So you can see here, when you try and reduce your cement, increase your cement replacements, and then also incorporate a hybrid structure involving timber, you can really see the impact of this. And something interesting that came out of it as well was looking at all the concrete that was used below ground and required specifically for the parking spaces. That was pretty much a consistent impact throughout all of the 3 situations. And the last case study I'll go on to is based on the TM65 methodology of calculating the embodied carbon of building services. And this was really a methodology that has been produced to use with manufacturers where no EPDs are available. So next slide, please. So the results I'm going to show form part of a larger study. And what it is using the TM65, you reach out to manufacturers. There's manufacturer forms, which essentially mostly include information on the embodied carbon, the material breakdown, of their products. And using this, you could complete a basic or mid-level calculation, depending on the amount of information they're able to give. And once they do that, you can then, you know, compare the global warming potential of different products. Next slide, please. So this is specific to radiators, and we looked at radiator size for a residential project. And the aim was to compare the impact of the different compositions. So based on their material type, we could see that cast iron is the heaviest in mass, as we'd expect. However, this does not mean that it had the highest kilogram CO2 equivalent when we compare this to an aluminium radiator that was much lighter. So the embodied carbon absolute figure was much lower. And we can see in the table below, when we look at the kilogram CO2 equivalent per kilogram for aluminium, it's way higher, as we would expect. So a key takeaway of this would really be to be mindful about the quantities of MEP, how it can be reduced, getting EPDs for products whenever you can, and really just to be aware and cautious of where these materials are being sourced from. Next slide, please. So I think that wraps up my presentation. Thank you everyone for listening in, and please don't hesitate to reach out to myself or my colleagues on the screen for any further queries on life cycle assessments. Thank you.
Great, thank you very much, Yara. And now we are going to have a bit of a panel discussion. But before we start, I've got Juliet Morgan, Head of Sustainable Development, British Land, who's joining the panel. And so, Juliet, perhaps I just start by asking you about your view of the, I'd say, willingness and ability of the construction and development industry to move away from using carbon-intensive materials, and is there a chance of being bolder and more innovative in exploring use of less traditional materials, do you think?
Yeah, morning, Peter. Thank you for the question and for including me in the panel. I think I'm really pleased to see a response that I think we've seen a lot more of in the last year, which is people being much more imaginative about applying materials. But at the same time, there's quite a lot of barriers in the way. So one that we've seen is insurances, being able to insure products, particularly around timber. Another one is about dependable supply. And then when you go to the sort of the certification and the recertification, more so the recertification of circular economy materials, going back to the first presentation from Arup, Isabel's presentation, there's a lot more that we need to be concentrating on. So I think the design industry is responding really well in terms of literally chasing through every product, every material, every carbon impact, but the rest of the industry around things like insurance supply and recertification is still needs more work. I'd also add that there is potentially room for more imagination, and what I mean by that is we're still talking about anodized aluminium facades. We can be talking about polycarbonate covered facades and save carbon that way. We're looking at things like rock wool for insulation, and there's other insulations around like mycelium and wool. So I think we need to be unconstrained by imagination on the design side and progressive on the policy side where we can be, but certainly heartened by the level of conversation and engagement I see across not just our developments, across the whole industry, really focusing on embodied carbon in ways that we weren't even 18 months ago. So and I think that message needs to land. There's still conversations about customers only being interested in operational carbon. Increasingly, with decarbonisation of the grid and the efficiency of buildings being so good, it is a heartening conversation to see an embodied carbon focus that's much more part of the industry's consciousness.
Great. Well, thank you very much, Juliet. Yeah. I think it's interesting. Changing views of insurance industry is going to be very important. I heard on Radio 4 this morning somebody on their business program talking about climate risk is investment risk, which I thought was a really big shift in terms of the people who determine how money is spent, and that sort of helps. Really big change, particularly in the development business, of course, as well as business more generally. So thank you very much for that. I don't know whether anyone in the panel is able to respond to Graham's comment about BREEAM. It'd be interesting if you're smiling, Isabel. That's something you would be able to say something about.
No, I'm not. I'm smiling because my scale is far more at the city level, but I completely agree it's a very important question. So I was looking down the side to see if anyone else had answered it, but unfortunately I'm not going to be able to answer that one.
Right, well, there's still time, so please do put your questions there. Yara, yes.
Yeah, I was just going to chip in. Not so much on the BREEAM side for the MAT 01 credit, but more on the GLA side. So I know specifically they've really enforced in their new London plan to complete whole life carbon assessments. They've specified really to push for using EPDs. And in terms of specifying benchmarks or targets, we can see in that document that they do state some figures that people can use to kind of set their projects at. And I believe those are, they've gone through case studies in order to set those per typology. So they're useful figures to look at, I think, early on in the design stages.
Thank you very much. So before I go to the Q&A panel, anyone else want to comment on that? No. Okay, good. So we've got two questions here from Dennis O'Keefe. And Dennis asked, hello, first of all, thank you for those excellent presentations pertinent to embodied carbon. BREEAM, which I guess most of us are familiar with, has been an established de facto broader environmental standard. Could the panelists please expand how BREEAM requirements will overlap with current evolving standard-based targets and say the calculations required to say scope 3 considerations? Happy to hook up with anyone else getting to grips with such matters. Can anyone respond to that or feel happy responding to that first part of Dennis's question?
I guess my response isn't so much of an answer as now I'm interested in SBTIs. So thank you for the question, and that's something for me to go and look at and see how it relates to BREEAM. So I can't give an answer, but I do find it an interesting avenue for us to see where materials fit into that one.
Great. Okay. Well, Dennis has put his LinkedIn connections in the box. So if anyone wants to hook up to discuss this with him, you can do that. But Dennis has asked the second question: is there now an established and verified embodied carbon database that designers and indeed enlightened clients, me perhaps, can point to and mandate in the use of, say, competing designs during procurement? So is there a database? Who's going to come and start on that one? Yes, Yara.
I can briefly touch on, well, the ICE database does have quite an extensive list of embodied carbon coefficients. Sometimes these are given as global averages. Aside from that, there's software tools such as OneClick, which also do have a lot of generic EPDs, as well as having manufacturer-specific EPDs. And I'd say these are sometimes interesting to look at when you can't get specific, manufacturer-specific EPDs for your products that you know of. So that might be a good starting point.
Anybody else? No. Okay. Not quite sure. It's MAD is the name on the question here. One, I don't know if this is something you can answer, Graham. This is a question about do you have a solution for the red mud residue for your virgin manufacture yet?
Indeed. Good question. I'm not a mining expert, but what I will do, there's quite a lot of material on the Hydro website in the mining area about how we deal with the effects and the impacts of mining, and red mud is most definitely a topic. What I'll do is I'll do a bit more research, and perhaps I can come back to the questioner offline. And because I was recently reading something on our intranet about how we're dealing with the issue of red mud. So I'm not an expert, but I can find out a bit more and come back to the questioner afterwards.
Thank you. And now a comment for Juliet, talking about polycarbonate facades. Problem with innovation, you run into new problems often. This one obviously has fire risks and high carbon. Do you?
Yeah, I think some of the challenge seems to be, and I think the question relates a little bit to fire risk. That what I see is, and I'm not dodging the question, but where you can save carbon and say things like timber and potentially PCP aluminium, we do indeed come into the territory of fire risk. And so the gap that I think is not quite being met yet is research and development and proof in this country in a way that meets the requirements of building regulations and fire regulations. So I think there is a role for industry to come together around R&D spend, or there's a role or an opportunity for government to, as part of levelling up agenda and research coming from universities and meeting our carbon targets, there's an opportunity, I think, for really proving through some of this research the efficacy of products that are sometimes harder for us to use. And I accept the point on PCP aluminium panels. Nobody wants to make unsafe buildings.
Good. Okay. Well, thank you. Perhaps I could ask you what, because I talked about involvement with COP in November. What do you all have plans to get involved, and what sort of impact do you think that's going to have on the debate in the UK? I mean, it's pretty important that we are doing it here. It does seem to be helping sort of spur on the government to be a slightly more adventurous in policies, and hopefully that will follow through with those. Graham, are you going to be involved in the debates, or how do you see it impacting on even your own corporate strategies?
I'm not sure that we're going to be involved directly in the debates, but I guess from a company or even from a sector, a materials manufacturing sector, the hard bit for us to always spot is how the multi-government or even single government targets and objectives and words like net zero on a countrywide basis, how they actually get translated into tools. And I guess for me, you know, we're looking at the UK government aiming at this future home standard, but as was earlier said, that's all about operational carbon. And what we're looking for is through the mechanism of government, how are we going to be propelled, encouraged, nurtured, forced maybe to pick up more of this, other than through sentiment and true, you know, belief in the principles of low embodied carbon, but how do governments go from saying how it should be to saying how it is going to be? And so I'm looking for something that might flow from that. That's from a pragmatic business point of view, if you like.
Well, so I mean, Paris was pretty important in changing attitudes. So Glasgow is going to be the same. So Isabel, I guess that Arup are going to be pretty highly involved in COP, aren't they?
I mean, that is the ambition, and I think, you know, in the next couple of months there's a lot of planning and conversations going on what form that will take. But I think, you know, kind of leading on from Graham's point, you know, it's absolutely critical that we have these conversations and more collaboration like this, and that learning, I think, and what Juliet said around imagination, that we give time and space for that, so that, you know, as we kind of move towards the strategic outcome of net zero and decarbonisation, that we're giving space and time for business models and operating models to catch up, and that we have that guidance so that, you know, the way that we as professionals conduct our basic work can catch up, and that's really kind of consciously thought through. So I think, you know, opportunities like COP to speak and engage and connect and collaborate in a new way, possibly, and the way that we bring our shared learning will hopefully really kind of accelerate that kind of trickle down. And, you know, I really welcome more steering on that from the industry and from our government.
Very good. Well, we're nearly up to time, but Yara and Juliet, do you want to just make a quick comment on that?
Yeah, sure. So all I would say is that in order to kind of push as much as we can, I think it's just important to kind of have a collaboration across the industry. So we really need, you know, good sources of data in order to be pushing our benchmarks and our targets, and pushing how far we can really go in terms of improving our embodied carbon.
I'll just add a tiny bit. I think we really need to know what the ask is of both our own government and the collective governments. And so, you know, there's a big contingent going up from UK GBC, and clearly a lot of industry support. What's really important is that it doesn't become a kind of environmental MIPIM where we all go up there, lots of conversations happened, and we all came back that, you know, we're very close to central government in London, and it's important to get a clear message, I think, and understand how government can act as opposed to just kind of supportive, nice noises. So that would be my only comment.
Great. Thank you very much. Well, thank you to all our speakers this morning. As I mentioned at the start, we'll be focusing on the climate agenda in the lead up to COP26 and afterwards, of course, as well. We'll be launching a research piece about London's climate resilience in September this year. So we thought we'd focus very much on London because people are coming from all around the world to the UK, and they can see the issues that London is facing up to, or indeed failing to face up to. And so that will be an interesting document which will be circulating in Glasgow and to all the attendees. And so we'll be doing a call out for submissions of people who have got projects that they really think would contribute to that soon. So please look out for that. And I just say that to the audience, we're going to have a short poll now, and it'd be very grateful if you could fill that in, because it's very, very useful for us in planning events in the future. And I'd like to end by thanking our panelists very much for a fascinating presentation and responses. Thank you very much, and goodbye.